Hello everyone, let's move on to question number 8 of the mock test for CET and let's see what the question says. The question has a figure that has been given to us, which is a network of 3 resistors connected at one junction on one side and connected to 3 different potentials on the other side. Of course, we will see how to solve this network, but for now let's see what the sum requires. The question says that as the switch S is closed in this circuit, we have to find out what is the current passing through this switch. And the options that are given to us are 4.4 ampere, 6 ampere, 3 ampere and 0 ampere. So we have to find out what is the current flowing through the switch when it is closed. The correct answer to this question is 3 ampere. Now let's find out how exactly would we get 3 ampere. So first I'm going to make a big beautiful diagram. Instead of this, I'm going to have a nice colorful big diagram, and this is the diagram that have been given to us. I have 3 resistors, each of them connected to a junction on one side and the other sides are all connected to different potentials. A is at 40 volts, B is at 5 volt and the ground is 0 volt. Even though it has not been explicitly written in your figure, you know the ground is always 0 volt. Then the resistor values are 5 ohms, 8 ohms and 6 ohms respectively for each branch. Now, you can see very clearly that this must definitely be a sum of Kirchhoff's laws because I have a node. Now, what has been asked is the current flowing through the switch. So, the first thing to understand is that the switch is in the lower branch. And any current that flows through the lower branch will flow through the switch, and therefore the question is actually asking what is the current that will flow through the lower branch if I close the switch. So let's close the switch and ask what is the current that will flow. Now I'm going to say that the current is going to begin flowing from A, and I'm going to call this current as I1. Now of course, why would the current flow from A and how do I know this? Well, for starters, A is at the highest potential, that is 40 volt, and we know that current flows from a higher potential to a lower potential. But as you must already know, that current can be taken to be in any direction when I'm trying to apply Kirchhoff's laws. This is because if my direction is wrong, the answer will come out to be negative. And then I can say that, okay, I must go back and find the right direction, that is the opposite direction of whatever I have taken. In this case, I have said that the current is flowing from A, it's going to move towards the node, and this node whose potential I do not know, I'm going to find shortly. So this current I1 will get split up into 2 currents, that is I2 and I3. So I1 splits up into I2 and I3. Let me tell you once again, you can take the starting current to be in any direction you want. For example, I could say that the current starts flowing from B. But if I do that, then I must say that the current flows from B and then it splits up at the junction and moves towards A and downwards. So I must have a consistency in the way I am writing down the current flow. And as long as I have this consistency and as long as I remember what signs mean in Kirchhoff's laws, I can use whatever direction that I want to take. Once I have done that, I can say that I1 is flowing from A towards the junction, splitting up into I2 and I3, and this is the setting for our sum. Now the unknown junction is having some unknown potential which I will denote as capital V, and I need to find out this unknown potential. So to do that, I'm going to first recall that incoming current at any junction or node is equal to outgoing current, and you can see incoming current comes from the left branch, that is from A, which is equal to the outgoing current, which is the right branch and the lower branch, and therefore the outgoing currents would be I2 and I3, and therefore I can write that I1 is equal to I2 plus I3. Now I want to write down an expression for each of these currents. To write down an expression for I1, I take a look at the left branch only, and then I say that okay, now I need the current in this branch, and from Ohm's law I know that current is nothing but potential difference upon resistance. So what is the potential difference in the left branch? It is nothing but 40 minus V, which is the unknown potential, divided by the resistance in this branch, which is nothing but 5. So this is 40 minus V by 5, the expression for the current I1. I want to look at the expression for the current I2, so I look at the right branch. In the right branch, again, I have to write down potential difference upon resistance. So what is the potential difference? It is nothing but V minus 5 upon the resistance, which is 8 ohms. And therefore, I have V minus 5 upon 8 as the expression for the current I2. And similarly, I have for the lower branch, V minus 0 divided by 6. So I have the expression for the current I3. Now, before you have this doubt, let me clear it already. Why did I write 40 minus V and V minus 5 and not V minus 40 or 5 minus V? To understand that, recall that in the left side branch, I have said that current is flowing from 40 towards V, which means I'm assuming that 40 is higher than V, and therefore I wrote 40 minus V. Then on the right hand side branch, I am assuming that current is flowing from V towards B, and therefore I have assumed that V must be greater than 5 volts, because then only the current can flow from V towards B, and therefore I wrote V minus 5, and the same logic applies for the lower branch. So this is the expression that I have to deal with. If I rearrange this equation, I will be able to find the value for V, which you can do by yourselves, and the answer will come out to be 17.54 volt. The final thing to do after I have this unknown potential V is to find the current flowing in the lower branch, which itself is nothing but the current flowing through the switch, which is exactly what we want. And the current flowing through the lower branch, as we have said before, is nothing but potential difference divided by resistance. Potential difference would be V minus 0 or simply V. And the resistance is nothing but 6. So I get 17.54 upon 6 because V is 17.54 and resistance is 6, and the answer comes out to be 2.9 ampere, which I will approximate to 3 ampere, and that is the answer. That is, the current passed through the switch is 3 ampere.